Hi guys, welcome to tutorial 1, question 1. Let's do this. Now I'm going to put the question right down here and for you to read. So pause the video and actually try to do it yourself before I go ahead and continue explaining everything. So just to clarify, we don't want you to actually give us the proof. We just wanted you to check to see if the given proof is correct or not. So just like the one on the bottom, tell me if that one is correct or not. So by reading this question thoroughly and look at the first sentence, we can see that, the base case is okay, but it should really be discussing binary strings and not just strings, you know what I mean? That's the kind of detail that as TAs, and Ilir and Michael can vouch for this too, that's the kind of detail we're looking for when it comes to a proof. And it's okay, but it should be saying that. Now, when you keep going in this proof, you can see that it says assume 2n, the arrow thing, 2 to the power of n. That is meaningless if you take a look at it. It begs the question, what does that even supposed to mean? That's the kind of thing that's frowned upon because it's not clearly defining what it's coming from. And I understand that this symbol can be found in courses like Mathematical Proofs, MAT 102, from some of you took it last year. But we shouldn't be mixing symbols. This kind of thing, instead of communicating more, is miscommunicating, because kind of something like this doesn't make any sense. Then the proof goes to say, we want to prove this for n plus 1, blah, 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 blah. Which is length 2n plus 2. I don't know why I did that. I thought the sentence would be longer. But the focus on this sentence, the issue with the sentence, is that when it says, we want to prove this. I know it sounds nitpicky, but it's not. We need it to be more clear when it comes to communicating your proof. So we can't have we want to prove this for n plus 1. We want to prove what? None of that alludes to we want to prove this for n plus 1. So communicating that is very important. Then you look at the last sentence. It says that each of these imply 2 to the power of n. Imply here is a poor choice of word. The proof is trying to use the inductive hypothesis, but it's really unclear about it. And again, communication is very important. And if this issue didn't happen a lot, we wouldn't be talking about it. But it's something that the students need to understand, that communication is very important when it comes to your proofs. So to wrap up this part of attempt 1 for exercise 1, the final answer is that due to the many miscommunications that this attempt has, this proof is not acceptable. Alright, so I'm going to put attempt number 2 right here, right now. And again, like the last one, please read it over. Pause the video, read it over, try to see from your own perspective based on what we just talked about if this attempt is correct or not. And then just press play and we'll continue talking about it. Alright, so you might be wondering why the lighting just changed. It's because when I explained this wrong the first time I did it. So, while I was editing, I came across this and I'm like, damn it, gotta record again. But for this part, it's better than attempt 1. It's much better. It goes to it shows the predicate, it shows the base case, it talks about the inductive step, the inductive hypothesis, the assumption is there, everything's looking good. But here's the problem. It's not explicit enough. Let's go through it. For example, the f function goes to show how many palindromes exist given the number, like how long the binary string is, correct? Well, assuming that fn equals to 2 to the power of n, they needed to go and showcase that 1 in the next step, the n plus, when we move to the step n plus 1, which they do mention, that, there is going to be, there's going to be 2 to the power of n plus 1. But where does that n plus 1 comes from? And once they have explained it, is it going to be unique? Here's what I mean. We already know, based on the n elements of the binary string, you can make 2 to the power of n palindromes. We already know that. That's an assumption that's already given. But now, if we add one length to it, adding a element before and after zeros or ones, right? You got to realize that now you can remake every single one of those 2 to the power of n palindromes from the nth step. You could recreate those by adding this new length to it. So, and they failed to mention that every single one of those new palindromes is going to be unique due to the new length. And that is something that is very important to be mentioned, mostly due to the fact that, my automatic response is going to be, well, what if they're repetitions? Or what if, some were like you can't make, you're failing to generate some of them. And, that is something that, that's something very important, but very small. But it's like, that's what's going to lose someone a mark. And that's what I mean. Like, it's not just about communication sometimes. Well, in the other attempt, it was, but in this one, it's more about the logic of it and making sure you don't forget anything. Like, there are some details that we're looking for them. We're really looking for them. And, but much better than attempt one. Much better than attempt one. All right, so that'll be all for this question, and I'll see you guys in the next video.